Now in this lecture we are going to implement our follow-up, which says that we need to implement a function pop_add based on the index, so we are going to perform a pop operation on a specific substack. But here we have a problem. The problem is when we are popping out an element from a specific stack, we have to move the elements from the stacks that comes after the current stack to the current stack, because in this case we will have a gap. So if I remove the, for example, first stack's top elements, so if I have some elements in the second stack, then in this case I have to remove the bottom element from the second stack and put it into the first stack, because in this case we have removed the top element of first stack. So to do so, we need another helper function in our stack class over here. So after the pop method over here, I'm going to create a new method which is responsible for removing the bottom element from this stack over here. So in this case, this method also will return the type of integer, so we have to remove the element from the stack and we have to return that element. So in this case, I'm going to name the method remove bottom, and here I'm going to create a new node which will get the bottom node. So in this case, new node b is equal to bottom. Then we are going to set the element that is located above the bottom element to be the bottom element in the current stack. So in this case, the bottom element will become the element that is located above the bottom. So in this case, if I set to bottom is equal to bottom above, we are removing the bottom element from this stack over here, and the element that is located above the bottom becomes the bottom element in this case. So in this case, after doing so, we are going to check that if bottom is not equal to null, in this case the below reference of the bottom element has to point to null in this case, because this is the last element in our stack over here. So bottom below will be null. Now after doing so, we are going to decrease size by 1 and we are going to return b.value. So with this, we have successfully implemented our method remove bottom element method in this case over here. So we are going to use this method inside this set of class over here. That's why I created inside this stack over here. So here, as I mentioned, when we are removing a specific stack's top element, we have to shift the elements that are located in the stacks that are located after this stack one step left. So in this case, for these purposes, I'm going to create another helper function over here, which is left shift. So this will be responsible to shifting elements one step left. So I'm going to declare this method like this, public int. So this is going to return also the value of the element that we are going to remove. So it's going to be like this, left shift. So in this case, as a parameter, it's going to take two parameters. So the first parameter will be the index. So this is the index of the stack in which we are going to pop out the element, and the next parameter will be boolean. So in this case, we are going to decide to remove top or bottom. So the first thing that I'm going to do over here is we are going to find the stack in which we want to pop out the element. So to do so, I'm going to create a stack over here, which will be the type of stack class. So to get stack, we are going to call stacks get method with using index that comes from this parameter over here. So based on this index, we can identify in which stack we want to pop out the element. So after doing so, I'm going to create a new variable over here, which will call removed item. And then I'm going to check that if remove top parameter is true, in this case, we are removing the element from the top of this stack. Otherwise, we are removing the element from the bottom of this. So I'm going to do it like this. If remove top, so this means that if remove top is true, so I'm going to pop out the element from the top of the stack by calling pop method and set that value to this removed item over here. So it's going to be like this, removed item is equal to stack.pop. Otherwise, else removed item will be equal to stack remove bottom. So this is the method that we have created over here, remove bottom. After doing so, we are going to check that if the current stack becomes empty, this means that we have to remove this stack from the set of stacks over here. So what I'm going to do over here is I'm going to write if condition like this. If stack.size is equal to 0, in this case we know that the stack is empty. So here I'm going to remove that stack from this set of stacks over here. So this set of stacks we have created over here, so which is the type of error list. So I'm going to call remove method based on the index. So here everything works smoothly. Now in the else condition, we are going to write the case that in which we have to shift the elements. So in this case, it's going to be like this. Else if stacks.size is greater than index plus 1. So this index comes from this parameter over here. In this case, we are going to create a new variable over here, which will be v. So then we are going to call this method recursively with the parameter of index plus 1, and remove top will be false, because in this case we are not removing the top, so we are removing the bottom element from the next stack, and we are going to push that element to the current stack. So that's why I'm going to call push with the value that we are getting from this method over here. So with these lines of code over here, we are taking the bottom element from the next stack and we are inserting that element to the top of this current stack, because in this case here we have removed the top element of the current stack, so this place is empty, so we have to fill it with the bottom element of the next stack. So that's why with this operation over here we are doing it. Then at the end we are going to return removed item. Now with this we have successfully finished left shift method. Now then at the end, the last method that we are going to implement, so as we said, it's going to be pop-at method. So pop-at method will be declared like this: public int pop-at. So it's going to take parameter index, so it's going to be int index. So here inside this method we are going to call this left shift method, so it's going to return left shift with the index of the index that we get from here, and top value is going to be always in this case true, because in this case we are removing the top element of specific stack over here. Now with this we have implemented top-at method over here. Now let's see how this is working in practice. For example, in this case, instead of calling pop method, if I put 0 over here for pop-at method, so in this case we know that it has to return 3 in this case. So let's run our code. So here we have an error, so I have forgotten to put stack.pop parentheses over here. So one more time after correction, let's run our code. You see that it's returning 3. So this means that our method works the way that we want. Now, for example, if I run one more time, so we know that 3 was the top element in our first stack, because we have set the capacity 3. So if we have inserted 3 elements, the 3 becomes top element in our first stack. Then it's creating a new stack and inserting these elements over here. Now the interesting moment over here is, let's check that moment as well. If I call this method one more time, so in this case it has to return 4, because when we are removing the 3 from this first stack over here, 4 is the bottom element of the next stack, so it has to become the top element of the first stack in this case. So if I call one more time pop-at method, in this case it has to return 4. So let's see how this is working. Now you see that first it returns 3 and the second it returns 4. So this means that our method works successfully. Now with this we have come to the end of this lecture. So in these 3 lectures I have provided detailed solution for the problem of stack of places. So hopefully everything is clear about this solution over here. So see you in the next question.